Good afternoon again, guys. So Teacher Jufil is back again to bring you more and more techniques, strategies, and approaches that you could use in solving mathematics problems. And for this afternoon, we are going to continue on our series, on the next part of our series, which is about solving problems that had appeared on the 2020 Metrobank-MTAP-DepEd Math Challenge for Grade 10 Eliminations. And before we go through with that, I am inviting you to subscribe to my channel, hit the notification bell so that you will be constantly updated with more upcoming tutorial videos. And kindly press the like button. Thank you. Okay, so this afternoon po, magkakaroon po ng kunting changes sa mechanics ng tutorial video na ito. Yung gagawin po natin, after those 5 problems and solutions to those 5 problems that I will be presenting, I will be giving questions that are similar to the problems that I have presented, which is for you to solve. And what you are going to do is to comment lang on the comment section your answers or your solutions to the problems that I will be presenting. And so, for our first problem this afternoon, this is continuation to the problems that I have given you in the previous video. Question number 1 is, find the sum of an arithmetic series with 20 terms if the first and second terms are 7 and 11. For this problem, what we are going to do first is to figure out what is our first term, what is the common difference, and the number of terms in the series for which we are going to find its sum. And obviously, based on the problem, since the first and second terms are given, then our first term is 7, second term is 11. We can find thereafter the common difference to be 11 minus 7, which is 4, and the number of terms in this series, as given in the problem, is 20, since we are looking for the sum of the series with 20 terms, with first and second terms as 7 and then 11. Okay, now if you could still remember the formula in finding the sum of the number of terms in a given series, arithmetic series, our formula is S sub n is equal to n over 2 times the quantity of 2 times the first term plus the quantity of n minus 1 times the common difference. So we have a way to derive the formula based on the formula S sub n is equal to n over 2 times the first term plus the last term. Okay. So this time we are going to plug in the values of our first term, of our common difference, and the number of terms. Not so much with the second term. We only use the second term and the first term to obtain our common difference. So let's plug in the values and evaluate or simplify. We have sum of the first 20 terms will be equal to 20 divided by 2 times 2 times the first term, which is 7, plus the number of terms, which is 20, minus 1 times the common difference, which is 4. Okay, now we can simplify this as 20 divided by 2 is 10 times 2 times 7 is 14 plus 20 minus 1 is 19 times 4. Then, after that, simplify inside the bracket. The sum of the first 20 terms is equal to 10 times 14 plus 19 times 4, which is 76. So the sum of the first 20 terms will be equal to 10 times the sum of 14 and 76, which is 90. So the sum of the first 20 terms will be 10 times 90, which is obviously 900. So therefore, the sum of the series or the arithmetic series with 20 terms whose first and second terms are 7 and 11 respectively will be 900. And for the second problem, find the sum of all odd integers between 10 and 150. For the second problem, we are told to find the sum of all odd integers between 10 and 150. So we are going to find the sum of all odd integers between 10 and 150, which means we are going to find the sum of the numbers 11 plus 13 and so on and so forth until 149. So what we are going to do here is to take 11 as our first term and 149 as our last term. Then from there, maybe we can find the sum of all numbers from 11 to 149 using the formula S sub n is equal to n over 2 times the first term plus the last term. By plugging in our first term as 11 and our last term with 149. However, the problem there is to figure out how many terms will be there from 11 to 149. In this series, 11, 13, and so on and so forth until 149. So what we are going to do is to use the formula for arithmetic sequence. Since this forms an arithmetic sequence, we will use the formula for the arithmetic sequence a sub n is equal to a sub 1 plus the quantity of n minus 1 times the common difference. We will plug in our last term as 149, our first term, which is 11, then the common difference, obviously, which is 2, and solve for n, since we will be coming up with a linear equation in one variable where n is our unknown. So let's try and solve for n. So we will have our a sub n, our last term is 149, equals our first term, which is 11, plus the quantity of n minus 1 times the common difference, which is 2. Then solve for n. So we'll have 149 is equal to 11 plus 2n minus 2. So you will have 149 is equal to, combine similar terms at the right, 11 minus 2 is 9 plus 2n. Subtract both sides with 9. You will have 140 is equal to 2n. Then divide both sides by 2. You will have 70 equals n. So therefore, the value of n here is 70. Meaning, from 11 to 13 and so on and so forth until 149, there will be 70 terms. And since we already have the value of n, we can plug in this formula in finding the sum of an arithmetic series. N with 70, a sub 1 with 11, and a sub n with 149. And you can simplify that, and ultimately you will find the sum. Okay, let's try. So you will have the sum of the 70 terms, since there are 70 terms in all, equals 70 divided by 2 times the first term, which is 11, plus the last term, which is 149. So the sum of the 70 terms will be 70 divided by 2 is 35, times 11 plus 149 is 160. So the sum of all those 70 terms will be 35 times 160 is 5,600. So therefore, the sum of all odd integers between 10 and 150, which of course are 11, 13 until 149, is 5,000. Okay, another faster way to solve this problem, especially if you will be dealing this under time pressure, is to use the concept about finding the sum of the first n odd integers. Like you want to find the sum of the first 2 odd integers is simply 2 squared, which is 4. The sum of the first 10 odd integers is simply 10 squared, which is 100. Now, if we are going to take the sum of all odd integers between 10 to 150, probably you can just take the sum of all odd integers less than 150 minus the sum of all odd integers less than 10. And you will get the sum of all odd integers between those two numbers. But how to do that? So, the number of odd integers less than 150 is simply half of 150, which is 75. So, the first 75 odd integers will be having a sum of 75 squared. Then subtract from it the sum of all odd integers less than 10. So, half of 10 is 5. So, there will be 5 odd integers less than 10. And the sum of those numbers will be 5 squared. Okay, so again, the concept behind this is there are 75 odd integers less than 150 and 5 odd integers less than 10. So the sum of all of the first 75 odd integers is 75 squared, and the sum of the first 5 odd integers is 5 squared. Okay, so by simply looking at that, if you find a hard time on squaring two large numbers, maybe you can make use of factoring difference of squares. So this is a perfect square, another perfect square, and the difference between squares can be factored as the sum and difference of the square root of the first and second term. So the square root of 75 squared is 75 plus the square root of 5 squared is 5 times the difference of those two terms, 75 minus 5. And simplify further, 75 plus 5 is 80 times 75 minus 5 is 70. 80 times 70 obviously is 5,600. So, the sum of all odd integers between 10 and 150 is simply 5,600. And for our problem number 3, what is the seventh term of the geometric sequence square root of 3, square root of 15, and so on and so forth? We are told to find a specified term of a geometric sequence whose first two terms are given. So, for problems like this, simply we have to go back to the formula that we use in finding the nth term of a geometric sequence. So, the formula, the general form for the nth term of a geometric sequence is simply a sub n is equal to a sub 1, which is the first term, times the common ratio raised to the number of terms minus 1. Meaning, for us to find the nth term, we need to figure out our first term, our common ratio, and the order of the term that we are looking for. Okay, as in this case, we are told to find the seventh term. So obviously, our n is 7, because we are told to find a sub 7. Okay? What else can be derived from the problem? We have the first two terms are given, square root of 3 and square root of 15. So, a sub 1 is square root of 3, a sub 2 is square root of 15. And if you have two consecutive terms in a geometric sequence that are given, from them you can find the common ratio. So how to find the common ratio? The common ratio is the quotient of a term divided by its preceding term. So the common ratio will be the second term divided by the first term, which is square root of 15 divided by the square root of 3. And the quotient is obviously the square root of 5. Okay, so we now have the value of our common ratio, of our first term, and the number of terms that are in the sequence. So this time, we can plug in those values in our general form and simplify. So you will have a sub 7 is equal to the first term, which is the square root of 3, times the common ratio, which is square root of 5, raised to the number of terms is 7. 7 minus 1 is 6. So the seventh term will be the square root of 3 times the square root of 5 raised to 6 is the same as square root of 5 raised to 6 is the same as the square root of 5 squared quantity cubed. Applying power of a power. So square root of 5 squared is 5. 5 cubed is 125. So square root of 5 raised to 6 is 125. So the seventh term is the product of square root of 3 times 125, which is 125 square root of 3. So the seventh term is 125 square root of 3. And for the fourth problem, find x if 8, x, y, 11 form a geometric sequence. For this problem, it is very essential that we need to know first what is the common ratio, because it will be the number that will be multiplied to a term to obtain the succeeding or the next term. So as in this case, we can only obtain the common ratio by using or manipulating two non-consecutive terms in the geometric sequence. It would be quite easier to find the common ratio if two consecutive terms are given. But it's different in this case. So how are we going to find the common ratio? So to find the common ratio, you can divide the fourth term by the first term. So that is a sub 4 divided by a sub 1. And for all we know, a sub 4 in terms of a sub 1 is a sub 1 times r raised to 3, because from the first term, you are going to multiply 3 common ratio to the first term to obtain the fourth term. So that will be a sub 1 r cubed divided by a sub 1 is equal to 11 over 8. So, dividing these expressions, you will get r cubed equals 11 over 8. Now, to solve for r, extract the cube root. So the cube root of r cubed is r is equal to the cube root of 11 over 8 is simply the cube root of 11 over 8. We can simplify this further as the cube root of 11 over the cube root of 8, which is 2. We cannot extract the cube root of 11 because it's an irrational number. So our common ratio is cube root of 11 over 2. Now we know already our common ratio, so thereby we can find the term next to 8 and even the term next to x. So we are only looking for the value of x. So the value of x is simply 8 times your common ratio, which is cube root of 11 over 2. So the value of x will be 8 times the cube root of 11 divided by 2, which is, after dividing, you will have 4 times the cube root of 11. So that will be the value of x. 4 times the cube root of 11. And for our last question or problem for this afternoon, find the sum of a geometric series with common ratio 2/3 and with first and last terms 1/3 and 8 over 81. You are told to find the sum of a geometric series with what only are given. The common ratio is 2/3. The first term is 1/3. And the last term, we don't know how many terms are there in this sequence, but it's just specified. The last term is 8 over 81. We are told to find the sum of all those terms. Okay, so definitely we have a formula that we can use. We already have learned formula that we can use in finding the sum of a geometric sum of all the terms in a geometric series. However, as in this case, we do not know how many terms are there in the sequence, because for all we know, we have the formula that we could use in finding the number of terms of a finite geometric series, we have S sub n is equal to a sub 1 minus a sub 1 r raised to n over 1 minus r. So if we will take this formula, we do not know first how many terms are there in the sequence. However, there is another formula that we could use if the last term is given. The first and the last terms of a geometric sequence or series are given, as well as a common ratio. The other formula is S sub n is equal to a sub 1 minus r times a sub n over 1 minus r. So we can make use of this if the first and the last terms as well as the common ratio is given. So as in this case, I guess it's not ideal for us to use this because we will be solving first for the number of terms. For how many terms are there in this sequence? Okay, so let's try using this formula and plug in those values in this formula. So S sub n is equal to, your first term is 1/3 minus your common ratio is 2/3 times the last term, which is 8 over 81, divided by 1 minus the common ratio, which is 2/3. Okay, and simplify it further. You have S sub n is equal to 1/3 minus 2/3 times 8 over 81 is 16 over 243 over 1 minus 2/3. Okay, so I have a different way in dealing with complex fractions. So if I already have a complex fraction, one thing that I usually do is to find the LCD of those fractions that you could find both in the numerator and the denominator. So those denominators are 3, 243, and 3. And obviously, they're common, the least common multiple of these numbers is 243. So we will multiply both numerator and denominator by 243. 243. So you will have 243 times 1/3 is 81 minus 243 times 16 over 243 is 16 over 243 times 1 is 243 minus 243 times 2/3 is 162. So you will have ultimately S sub n equals 81 minus 16 is 65 over 243 minus 162 is 81. So the sum of all those terms with the geometric series whose common ratio is 2/3 and whose first term is 1/3 and the last term is 8 over 81 is 65 over 81. However, for problems like this, I guess since there are only few terms, I guess, which will be added in this series, considering again that the first term is 1/3 and the last term is 8 over 81, simply looking at the progression of the numbers from 1/3 to 8 over 81 with a common ratio of 2/3, there will only be few terms between 1/3 and 8 over 81 that will be added to this series. So let's try. 1/3 times 2/3 will be 2 over 9. Then 2 over 9 times 2/3 is 4 over 27. Then 4 over 27 times 2/3 is 8 over 81. So from 1/3 to 8 over 81 with a common ratio of 2/3, there will only be 2 more terms to be added in between them, or geometric means between them. So we can immediately take the sum of all those terms, since we will be looking for the sum. That's obviously with a less common denominator of 81 divided by 3 times 1. That's 27. 81 divided by 9 is 9 times 2 is 18. Plus 81 divided by 27 times 3 is 12. Plus 81 divided by 81 times 8, that's 8. Then take the sum of those numbers on the numerator. That's 27 plus 18. That is 45. Plus 12 and 8 is 20. That's 65 over 81. So I guess for only few terms in a geometric series, it would also be quite easier to just do this. So ayan guys, those were the ways on how we could be able to deal on those problems. And if you have your ways of solving or your approaches in solving those kinds of problems, you can also share it on the comment section. And this time, I would like you to solve similar problems, similar to those that I have given you or that I have shown you just earlier. And I am challenging you to post your solutions or your answers to the problems on the comment section. Okay, thank you again for watching guys, and keep tuned in. And again, don't forget to subscribe and hit the notification bell so that you will constantly be updated with more upcoming videos in this series. Thank you and God bless.